Let's do the next one, that is the fourth one. Okay, here it says show that the four conditions are equivalent. So we have to show that these four conditions are equal. Okay, so we'll take the first and the second, that is A is subset of B, and the second one is A minus B equal to 5. Okay, these both are equal, we'll show B. Okay, see, A is a subset of B means you know that all the elements of A are in B. Okay, and A minus B means all the elements which are present in all the elements which belongs to A but does not belongs to B. Okay, that that is A minus B. Okay, so when is A minus B 5, that means there are no elements that belongs to A only. Okay, that means those elements also belongs to B. That means then we get an empty set. Okay, so we'll take an example. See, if A is a subset of B means all the elements of A are also present in B. That is, if A is equal to 1 2 3, then B equal to B also should be 1 2 3. All the elements of A are in B. Okay, it can have 4 5 also, no problem, because A is a subset of B means all the elements of A should be in B. It doesn't matter if B is having 4 5 6 and more. Okay, you know that. So here A is a subset of B because all the elements of our A are in B. Now what if it's, so we can say this A is a subset of B. So what about A minus B? A minus B, if you take A equal to 1 2 3, then B equal to 1 comma 2. Okay, then A minus B will be all the elements that belongs to A and does not belongs to B. See, this element belongs to A but does not belong to B, so we can say A minus B equal to 3. Okay, this belongs to B, this will get cancelled. 2 belongs to B, this get cancelled, the remaining is 3, so 3 is the A minus B. Okay, if 2 is having, if this is the condition, you see there is no such element which belongs to A and does not belongs to B. See, all the elements of A belongs to B, so we can say that A minus B equal to, we don't have any elements, it's 5, it's empty set, because 1 is here in B also, so 1 get cancelled. 2 also here in B, 2 goes out. 3 also is in B, so 3 also goes out, so there is no element that belongs to A, so we can write A minus B is equal to 5. So now this is, we have to write theoretically to prove that A subset of B is equal to A minus B is equal to 5. Okay, so if it's A minus A subset of B means we can write all the elements of A are present in B. Okay, all the elements of A are present in B, so A is a subset of B. That means we can write, if X is the element, then X belongs to A and X belongs to B also. Okay, which implies that A minus B is equal to 5. Okay, this implies that A minus B is equal to 5 because there is no such element which does not belongs to B, because there is no element X, okay, no element X such that X belongs to A and X does not belongs to B. Okay, this is the reason. That's it. This is how we prove that A is a subset of B and A minus B is equal to pi. Okay, 5. Okay, because here A minus B means all the elements that belongs to A and does not belongs to B. Okay, there is no such element X such that there is no element X such that X belongs to A and X belongs to B. Okay, so A minus B equal to 5. Okay, A minus B equal to 5. That's it. See, now let's do the next one. We'll take 1 and 3. Okay, if we take 1 and 3, let's take the first one, that is A subset of B, and third one, A union B equal to B. Okay, now let's prove that these both are equal. Let's take A union B, okay, and prove to be this first one. Okay, A union B equal to B. Let's take this. Now let's take, okay, let x be an element, x be an element of set A. That is x belongs to A. Okay, let x belongs to A. Then we can say that x belongs to A union B also. Okay, if x belongs to A, then A union B also will have that element. Okay, now it's given A union B is equal to B, so we can write x belongs to B. Okay, A union B is equal to B, so we can, instead of A union B, we can write B. Since given A union B equal to B, okay, x belongs to B. Now we have taken x belongs to A, but we got x belongs to B. Okay, that means all the elements of A is in B, so we can say that A is a subset of B. Okay, this is first one, so we have proved this one to be the equal to the first one, A subset of B. Okay, that's it. Now let's prove first and fourth. Okay, that is A subset of B, and the fourth one, that is A intersection B equal to A. Again, let's take this and prove to be this. Okay, that is A intersection B equal to A. Now again, let's take an element. Let x be an element of set A. Okay, that means x belongs to A. Okay, x belongs to A. Now we see it is given that A intersection B is equal to A, that is A is equal to this one. So instead of this, we can write this. So we can write x belongs to A intersection B. Okay, also we write reason, since given A intersection B equal to A. Okay, now if x belongs to A intersection B, then x is common to both, so we can write x belongs to A and x belongs to B. Okay, so now we have taken x belongs to A and we got x belongs to B. Okay, so we can say that all the elements of x is also in B, so A is a subset of B, so we can write A is a subset of B. Okay, so now we have proved this to be this. Okay, that's it.